My name is Tomasz Czajka. I'm here with Ciaran, Gaffney, Pascal, Schlumpf from Tenable, and we are SRE at Tenable. So, Tenable has an important mission, we believe. It helps the organizations to discover and fix cybersecurity gaps before attackers can exploit them, right? So not after, but before. We call that exposure management, cyber exposure management. Right, so cybersecurity is a data problem today. We have our different type of scanners. We scan infrastructure, IT, OT. We blend it with the data coming from identities, like think of IAM from AWS or AD. We blend that with third-party data and with some intelligence from our research teams. So all of this data needs to be ingested and available to customers in a timely manner. So what reliability means to us? So to Tenable's mission, reliability is make the data available to customers so they can make use of that. They need to fix their security gaps, right? So for us, reliability is not just systems are up. For us, the reliability means customers can make informed decisions to protect their environments. So what do our customers care about and don't? So our customers obviously care about getting access to all of this data in timely manner. It takes half an hour to write an exploit, for example. They need to know about this stuff quickly. What they don't care about is that microservices are crashing or that database is overloaded. They care about the UI being accessible quickly. They care about being able to use API to export this data to other systems, but not the fact that database is simply overloaded or running hot on the CPU. So is our product reliable, right? When we think about what reliability means for our customers, let's ask this question ourselves. And we keep asking ourselves this question. So if we ask engineer, developer, do they think the product is reliable? They will, if they are on kind of mature way, they already have SLOs defined on microservices, 4 golden signals, everything as needed. So they look at the SLOs and say, yeah, it's green. It must be reliable. But customers might be still complaining that the feature doesn't work as expected. The data isn't available or things are generally slow. Conversely, if services are crashing and developers see that, they say, okay, our product isn't reliable. But in fact, customers are super happy. From their perspective, everything works as expected because our architecture design handles those crashes. So let's ask product management. By the way, the engineers, they don't often see the full picture because the product these days is sliced into microservices, right? So we look at 1, 2, 3 microservices and don't necessarily see a bigger picture, see the bigger value delivered to a customer, the whole feature. So let's ask product manager. Do they think the product is reliable and how do they know that? So if they are smart, they maybe look at all the SLOs from microservices, average them and say, yeah, that looks reliable. More likely, they will look at the number of escalations, number of Jira tickets, talk to the support, which kind of gives you a good outlook. However, all it gives you is a bad news, where customers are complaining, so you don't see the good side of the product. So it's not really a balanced view. So we ask 2 questions. So question number 1, how can we define reliability in an organization that we all see that in the same way? And the second question is, how do we show these reliability numbers or reliability to the whole organization so we all understand it the same way, but with the single view, we can iterate and improve, and that is tied to a customer experience. So we move from the service reliability to kind of product reliability here. So we decided to take a flipped approach. So instead of us engineers trying to define reliability through SLOs for microservices and their dependencies, we want to sit down with the product manager and ask, because we cannot ask our customers directly, there's like 44,000 of them, so we can ask product manager, what do you think is important for the customers? Give me 5, 10 main features from your product area and tell us what customers care about in terms of reliability. And we as engineers, we can codify it, we can measure that. And if we can measure that, we can improve it. And ultimately, that leads to customer satisfaction here. So, again, so we are moving from the service level reliability to the product reliability tied to customers' experience. So as an SRE team, we went through kind of different restructures in order to support the product reliability better. So initially, like many of us, we started with a single core SRE team that at some stage was driving SLOs with the product teams. So we embedded those SLOs to microservices, or we work with product teams and they embedded some of those It was a great start a few years ago, but we realized that it didn't drive the product reliability well. There were no processes associated with that. There was no SLO review, and we figured out that this doesn't really drive reliability. Something else did, but not necessarily the SLOs themselves. So we came up with a better approach at some stage. We embedded SREs into the feature teams, product teams. SLOs wasn't the main driver here. The main driver was to actually increase the productivity of the feature teams, of the product teams, by disabling those barriers. So think of DevOps, right? There was a great talk earlier about that. But the SLOs were a side effect of that. Because we embedded SREs into the teams, we suddenly started seeing SREs thinking about the SLOs, thinking about the product, and they get closer to the product itself. In the previous model, we weren't that close to the product. Now we were, and we came up with the better SLOs. We started thinking about the product reliability. In the core SRE team, we already had passionate engineers. They are sitting here, we'll be talking about it. And those engineers came up with a framework that we also used by embedded SREs. And they got the feedback from the teams. However, this model wasn't great for a couple of reasons. One reason is that there were silos between the embedded embedded teams, SREs in the teams. Another one was that it was hard to scale out because we would have to embed SREs in every team. We didn't have so many SREs. So here's the third model that we are using now. Take passionate engineers about the SLO, about the product reliability, both from the feature teams, embedded ones, and from the core team, and build one mission-focused team on the product reliability. So we did it, and the result of that is we interact with the feature products, with the feature product teams. We onboard the SLO framework that we continue developing. We also onboard this SLO framework to the core SRE team, and they use it against the infrastructure in the same manner. We work with the teams to help defining what reliability means to them, working with the product managers and so on, and ending up with the SLO reviews that build this whole reliability feedback loop. So here's how we build it. There's three steps. I'm going to present this really quick. So first of all, in this whole process, what's important is to establish the relationship with the team. That's how we all start as a team, this journey with the team. Because we had some experience already with product reliability, we bring it to the teams first. Relationship, second of all, define the reliability. This is the meat of what we do, right? And Ciaran is going to talk about it. So we engage with different parts of the team, and all the data ends up with the automated framework. And then finally, Pascal is going to talk about how we create this reliability feedback loop out of this information. So from the automated framework to automated tooling with the data, through the regular reviews with the team, we end up with feeding action into the sprints. And over to Ciaran to dig into that deeper.
Thank you very much. Yeah, so when we started our journey on the SRE application team that Tomasz had built, we first asked ourselves, what does product reliability actually mean to the wider Tenable engineering organization? And most importantly, what does it actually mean to the Tenable engineering teams? So historically, it meant that the services that they owned delivered on their intended purpose within the vast distributed system that they were a part of, without unexpected downtime or performance issues. An incident might be spun up because an engineer got an alert, and you'd see messages in Slack like, well, the dashboards say that the pods are up, topic lag looks good, and we haven't had any CS tickets yet. So we typically measure it with graphs and logs in our observability platform, and monitors and alerts. And as I mentioned, regrettably, CS tickets. And I mean customer service tickets, by the way, unless that isn't clear. In some rare cases, as Tomasz mentioned, there is some SLOs that were scattered across the teams, but none of them were really standardized, and they weren't really driving reliability improvements. So that's what it means historically to the engineering teams at Tenable. But internally to our customers, it means that it just works. It's guaranteed excellent user experiences, preventing disruptions that could impact the objectives that they're trying to complete with our product. And that's important, is understanding what the objectives actually are. So we initially tried to focus on service level reliability for the hundreds of microservices that makes up the Tenable architecture. However, without tying those signals to actual customer impact, we had no clear picture of how our users were actually affected. In a recent talk that we attended at SREcon actually in Dublin, Heinrich Hartmann from Zalando posed the question to the crowd, essentially, that if you had only had one monitor, you could only set up one single alert, it would measure user impact, and I'm pretty sure most people here would agree with that. And not just whether a service is crashing or your Kafka topics are lagging behind, right? So we knew that we needed to align our approach to SLOs, to user experience. So we looked back at the Google SRE book and we adopted an idea of modeling the team's product area around user objectives and user steps. For example, a key objective for Tenable's product, we're a cybersecurity company, as Tomasz mentioned. We have a feature for scanning your infrastructure for vulnerabilities. One of the objectives might be to launch a scan. And the steps involved in that key user objective is to list the scan templates, get a scan config, edit the scan config, and then launch the scan. And each of those actions has a critical API that's backed by a subset of our many microservices that are owned, or the ownership is spread across multiple teams. So by clearly defining the objectives and steps like this, we can directly link reliability of those APIs to actual user experience, and develop SLIs and SLOs for each of those user steps that mirrors real-world impact on the actual customers. So we knew we needed to prove out this idea of building SLOs from a user-focused perspective. So we needed to start small with a newly acquired product or feature. We had a recent acquisition, a small team that was being integrated. This kept our scope manageable and allowed us to learn and iterate quickly on the approach. So first, and Tomasz kind of touched on this slightly, is we talk with the product managers to define the user objectives. And you might have 4 or 5 critical user objectives for a particular product. In this case, we have, I think, 5. These are the primary goals the customers want to accomplish. Next, we have a few meetings with the engineering leads to map out the actual user steps. The engineering leads tend to have a better understanding of the intended user flow for each of the user objectives. So that was a good touch point for actually building the user steps. And you can see on the diagram, it's clear that when you map out a product like this, certain areas become, and I realize now you can't really see the lines on that, but essentially some of the user steps show up as choke points on the user journeys. So it's very easy for us to assign criticality to specific parts of the product. And then that allows us to focus our efforts when we're building our SLOs. And I think the most important bit then is working with the wider engineering team that owns these products to understand the dependencies for each of these user steps. So we actually add metadata to our product model to tell us which services are involved in each user step, and also which backend infrastructure is backing those services. So now it actually is very easy to also assign criticality to pieces of infrastructure and individual services. So we can say that when the graph database is down, that 3 of our user objectives aren't completable. So we can then drive our SLO process through that. So I want to touch on this briefly. Because SLOs are a deep project, subject, and we don't have all the time in the world. But some of the lessons that we learned from building SLOs for user steps in particular is to measure user experience and not system health. I think that's kind of self-explanatory. You can see on the diagram, something typical that we would have seen at Tenable is a service that's owned by a service team, like Service Web Backend, interacts with Service Search, which probably hits a database, and they might have a metric on a dashboard, or it's driving a monitor for execution time, and it's an average. And that might be paging an engineer and driving incident creations at some time. So we decided we needed to get closer to the user, right? So we instrumented our metrics at API gateway, which in our case is just a typical API gateway. It's a service that lives in a service cluster, and that was better because we've got standardized metrics for every single API that we care about. The tags are all the same, and we can build SLOs in a standard way that way. That really isn't good enough, though, because as you can see, right, if you measure at API gateway, if something is wrong at our load balancers, if our load balancers don't even exist anymore, you're not going to see it on your SLOs. So we need to move closer to the user, even closer. So we were actually in the process of instrumenting request-based metrics at Cloudflare, and we've we're writing a transformer that's able to take our Cloudflare logs and write them into our observability platform for particular APIs that we care about. I don't know if people are familiar with Cloudflare's offerings when it comes to metrics and integrations, but you can't get granular metric tagging for particular routes through their console and through their metric integrations. Yeah, so that now we have metrics that allow us to actually measure the performance that the user is going to see as close as we can get without actually measuring metrics at the browser. And lastly, it's important to use the right aggregations. I don't know, most people are probably aware of this, but averages can mask outliers that degrade user experience. Percentiles will highlight the worst cases, which often matter most to users. So if you're using percentiles, you're probably on the right path. This is a quick slide about the kind of anatomy of a user objective SLO. And again, I think the coloring here is not helping. But so we codify our SLOs and that product model that I showed in a framework that Tomasz kind of briefly mentioned and Pascal will get into. We also have the framework also covers the process, but this is just a visualization of what it looks like to build SLOs for a user objective. And you can see on the inner squares, the SLOs themselves, they're assigned to a particular user step. They might look at latencies and error rates for a particular request API. And they're consistently tagged with a particular SLO name, and then they're tagged with their user step, and that's all rolled up into a user objective, which is also tagged. The power of building them like this and standardizing the tagging in your observability platform means that we can build SLOs for multiple user steps for a particular user objective, and then roll up the values so that we can get an overall view of the user objective itself. And you can also see that in some cases you might have two APIs that drive a particular user step. We just combine those SLIs into one SLO. So you kind of be flexible that way. So yeah, I'm going to pass over to Pascal now to talk about the framework that I mentioned.
Sir. Alrighty. So yeah, I'm talking a little bit about the framework that Ciaran mentioned a couple times and Tomasz as well. Basically what we did is we built this framework in Terraform with different modules and folder structures, and there's a little bit of logic within those modules. So we have the ability to hand that framework to developers, and they can turn certain things on or off or fine-tune them to whatever needs they do or they have. And basically this allows us to have a couple small inputs on the left-hand side and get a bunch of output from this. So we can see here that we have our monitors and alerts get created from this, our SLO object like Ciaran covered, and then our dashboarding. And basically one thing that we try to encourage developers is to use those error budgets and burn down alerts that get created from this dashboard, from the framework, to really measure the customer impact, and then don't rely on the monitors that they created before, because this measures the customer impact. If you have an error budget or burn down alert on this, you will catch the customer impact. All of this is very easily tweakable, so we try to make it as easily usable to the developers as possible. And then in addition to that, we are in full control of it, which means if we do want to make changes to the framework, we can easily do that without having to consult developers first. Another addition that we did here is we added auto documentation into it. So this guarantees that our documentation is always up to date. If you want to change a SLO threshold, for example, you can do this in one simple place, and it will be updated in our Confluence, and it's easy and good to go. Basically, to kind of summarize this, the framework allowed us to really standardize certain things, such as monitors and error budgets, and the alerting off of that. It enforces its best practices for the developers to say, don't create 1,500 alerts that you never look at. Here's a couple that we provide, and we've seen quite a bit of success with that. And since we are in full control over the repo, we can make changes on the fly as we see necessary with feedback from the developers as well. In addition to this, we have labeling and tagging, like Ciaran mentioned before, and this kind of helps us create this report. And this report is important in the sense that we have almost too much information available to us. So there's a bunch of dashboards out there, there's a bunch of SLOs, but this report basically concises it into a format that developers and product managers can understand easily, and then have this available on a weekly basis. So looking at this report, it basically generates all the breached SLOs that we see on a weekly basis, and it's very easy to then annotate and comment on this. So if you do have a breached SLO, maybe there's a bad rollout, just note that in here, associate a ticket with that, and you're pretty much done with it. In addition to that, since we do find the report quite useful and it drives our SLO reviews, we try to make it as easily accessible to developers as possible. So we give them Slack reminders saying, hey, here's the latest report, just click on this and you're good to go, right? Since reports aren't necessarily fun, but they are useful in our case. So now with this report in hand, developers can go out, and there's couple little links at the bottom which are barely visible, but they can basically click on that and then get into their dashboards. And these dashboards are again created by our framework. Here we found that the hierarchy of the dashboards is pretty important. The hierarchy allows people that are not familiar with the product to still navigate through the dashboards that they're familiar with, and then get the information that's useful to them. It also creates that cohesion between the service level objective and then the services that are actually supporting it, since you can daisy chain your way all the way through. So I want to talk a little bit about our different views that we have, and one of the most important dashboards here is what we call our executive view. Here, what's really important is basically big, bold numbers and what we call our reliability score. So it's for somebody who's not familiar with the product itself, they can still kind of get an idea of how a product is doing based on the SLOs underneath. In our case, this is broken down by site, and then that's presented in an easy way. Moving on to the engineering view, this is more detailed, and this is typically what engineers use to do their SLO reviews. A lot more detail, color-coded. In our case, we try to include the events in a time series data or in a time series format. So if you do have an incident, at the bottom you see those are annotated there, so it's very easy to potentially correlate certain SLO breaches with events. Now, with all these artifacts in hand, this is basically part of the tooling we built to support our processes. And I want to talk just shortly or briefly about the processes that we put in place. And this is basically the closing the feedback loop, right? So now we have all this data, we have all these artifacts. The process now is basically split into 3 different intervals. So we have our daily process, our weekly process, and then our monthly process. Daily obviously would be alerting and then looking at dashboards. Our weekly process would be that production report that gets generated and having those SLO reviews drive certain breaches, take actions based off of that, and then we try to create another automation there, since we like to build stuff, to make it easy for people to start ticketing certain things and then put those in the backlog. And then the monthly thing, where we look at the overall long-term trend of how certain product areas are doing, and then make sure that those are actually improving in the direction that we want. Lastly, to kind of close that feedback loop, it was important in the beginning to get buy-ins from the teams. So even if they don't necessarily want to spend a lot of time on certain reliability work, the feedback loop still helps to create those tickets, put them in the backlog, and then those can be leveraged at some point to potentially start asking for more requisitions, or in our case, just prioritize reliability work, right? Since if you have a large backlog, that won't be good. And another thing here is incident review. So for every incident we have out there, if it's not caught by an existing SLO, we try to fill that gap as much as possible. And the important thing here is we try to do it in a holistic approach. So if we have something out there that kind of works, that's better than nothing at all, and will make it better in the future, right? And with all of this in place, we basically saw quite a bit of improvement. We saw a lot of red going into green, which is good in our case, and that means more stability, more reliability, and then eventually, hopefully, happier customers. Handing it back to Tomasz.
Thanks, Pascal. And with all of that, we are still learning, just like you, just like everyone is learning about the reliability more and more. So quick things, what to do from our perspective, what we learn, is to plan early. Teams are busy, teams schedule their own stuff, they work on the features, right? So we have to plan that early and be respectful for that. Otherwise, we'll just try to scramble. Build relationships, don't forget about this. Include product managers. They are valuable source of information, right? We typically skip them in the past. Think of ownership, both on the product side, so products should own this process eventually, but also remember that each of the SRE members should also have this ownership of certain relations with the team. That works the best, what we found. Engage product leaders monthly to kind of enhance that loop. And I enjoy the outcome. Out of that, you have happier customers, that's for sure. Less escalations from the support that was flooding the engineering organizations typically. You will see incidents will start to be driven by those user objectives, SLOs, and not by other metrics. And then eventually you end up with a better collaboration between SRE and the product. And with that, again, please come talk to us. We'd also love to learn from you. Thanks, guys.
Thank you so much for the talk. It was really interesting to hear. One question that I have, I think the idea is great, you essentially focusing on your customers, but from their talk, I'm not entirely clear. How do you actually get the feedback loop from the actual customers?
Mm-hmm.
Product managers, product owners, they're great. But there is an assumption then that they have a proper feedback loop to measure your improvements and make sure the customers are really happy. Yeah. So how do you deal with that, if you don't mind me asking?
It's a great question, right? So I think one of the things we can measure is the number of the CS tickets coming from the support. So this is why kind of breaking the silo between us and the support as well will give us information. That's one of the sources of information that always product managers were getting through the CS ticket, through the CS escalations. And that's a good source of information. We also work with product operations. So this is the team who embedded kind of things like Pendo, Amplitude into the product, and they can also measure the customer engagement, but also some of the metrics from that perspective. And that also counts into that. But I think the escalations from the support plus the feedback coming through the product managers from the customers is also what's important here. Product managers in our organization work directly with customers as well. So they are kind of their ears here.
Thank you for the talk. So as far as I understand, you measure per API P95s at the Cloudflare layer, but then you want to compose them and get information about user workflows that might involve multiple calls to the APIs. And so does that require tracing? How do you compose the different metrics into the user journey? Maybe if multiple journeys use the same building blocks, maybe some of the flows are more expensive and some of them less.
Yeah, I feel like it's the best questions to be answered by Ciaran. So Ciaran, I hand over. Yeah.
Yes. So we actually build we do those that composing via the SLOs themselves. So. You're right in saying that certain user steps are used throughout multiple user objectives. They will have an SLO each, but the user steps are reused. So in our observability platform, you might have 5 user objectives and 13 user steps, whatever, but the user steps are reused for each user objective through tagging, right? So that way you're able to get that composition, and we typically use a minimum. If we're looking at the overall user objective, we look at the minimum aggregation so that we can see when there's problems with a particular user step on that flow.